Welcome. This is the 2.05 the least squares regression line video. In this lesson there were two applets linked. You probably had trouble running them, so I'm just going to show you some applets right now. If you're interested in having them run on your computer, I can show you how to do it, but it is a bit of a pain. So for this first one, basically we just have a grid. The middle point is currently 0, 0 because that's how I have my scale set. And I can just go ahead and put dots down. Now, the whole point of statistics is to try and take data and try and figure out, what is the data telling us, what kind of trends are occurring, what is the relationship between whatever the two variables are. And in order to do that, there are a variety of things we do. One of the first ones is to try and get a line of best fit. What is the trend of the data? Does it tend towards a linear progression? And one of the ways we do that is with linear regression, which is trying to reduce the data down to an equation that it approximates. We're never going to be as exact as the original data will be, but sometimes the original data is thousands and thousands and thousands of pieces of data. So if I click show line, it will show me the line of best fit. So for the data I've put down, it has reduced it into a line, and it gives you the equation of the line right here. In some of your answers, you're forgetting to include the y. The y is, and it should have a little hat over it, the y hat is part of the equation. And I like to go to Wikipedia and copy, I just Google y hat, and I can copy that character right off the Wikipedia page, which is pretty helpful. So that's y hat. This is my equation for this line, and this is the line of best fit. This is the line that best fits the data if the data is a straight line. And remember, the correlation coefficient will tell you how close the data is to actually being that nice straight line. Okay, so that's interesting, but it doesn't really tell us about the least squares regression line. So let's take a look at a slightly more complicated app, which is this one. Now on this one, I can put my I only get 5 pieces of data. I can put my 5 pieces of data wherever I like. And then this line can be moved around, can be moved up and down, and it can be kind of torqued around. So if the 5 red dots are my pieces of data, and our goal is to regress the data into a single line that we can use to make predictions or just simplify the data down to a single equation, this is one way you can do it. So you have your data points, and you draw a line down from your data point to what we think might be a line of best fit. This black line is called the residual. And then, so we have our 5 pieces of data, and we have our 5 residuals. Now the concept with least squares, and the reason we're going to square the residuals is because if we added up all of the residuals and we had a line of best fit, all of the residuals should sum to 0. They should all cancel each other out. The negative ones should cancel out the positive ones in a line of best fit. I may not be at that right this second. So we square them because then it won't matter if they're below the line or above the line. Our goal is to minimize that area inside those squares. So here is our first square, our second square, and basically they just squared each of the residuals. And down below you can see the length of each of the residuals. This first one's kind of short. The second one is longer. This must be the third one probably. Fourth one, and then the fifth one. And then they square them basically to get rid of the sign. I don't know why they don't just do an absolute value, but this is what they do. So our goal is to make our squares, the sum of our squares, as small as possible. So this number right here is the sum of our squares. So we want to create the line of best fit by making that number as small as possible. It's bigger. That is smaller, smaller. So now here I'm creating the line of best fit manually. All right, now I'm going to try and hork it and make it a little smaller, smaller, 17, smaller, small. Wait, it switched there a second ago. Somewhere here. So this is my manual line of best fit that I just created. And I know it's the line of best fit because I have the smallest value for my squares, for the sum of my squares. And then this would be the least squares regression line. Using the smallest possible squares, I've regressed my data down to a line. This should be my line of best fit for this data. And that is what the apps were trying to show you.